Good morning, all. We are going to talk about the master series, the overview of all the episodes of the decoding healthcare fraud with AI and graph intelligence. So, in this series, we are not going to start a typical AI series. We are starting an investigation. So, what if I told you that healthcare fraud is not committed by a single individual, but by a network of actors working together? A doctor, a patient, a clinic, sometimes even a lawyer, all connected in ways that are not immediately visible. And here's the real problem. Most AI systems today completely miss this, not because they are weak, but because they are looking at the problem the wrong way. They look at rows of data, they look at isolated transactions, but fraud is not isolated. It lives in relationships. The entire series is about shifting that perspective. It's about moving from isolated machine learning models to connected intelligence systems that can actually detect how fraud operates in the real world. Let me walk you through what we are going to build across these 10 episodes, and more importantly, why each step matters. In episode 1, we begin with something most people underestimate, or understanding fraud itself. Not from a definition standpoint, but from a system perspective. We will break down who the real actors are, how they interact, and what patterns exist in the real world fraud cases. One key insight you will discover is that fraud is rarely an individual act. It is often a coordinated behavior across multiple entities. However, most detection systems treat fraud as an individual anomaly. That is the first blind spot. We'll also uncover a major gap. Certain actors like attorneys are almost completely missing from most fraud detection models, even though they play a critical role in many real-world fraud schemes. This episode sets the foundation because if we don't understand the system, we cannot model it. Episode 2, we move into the data in episode 2. So we explore structured healthcare claims data, which is the backbone of most fraud detection systems today. We'll work with real world data sets and build a strong machine learning model, uh, like any machine learning algorithms that you use, classification models. At first, this might feel sufficient. The model will give you good performance. It will detect patterns. But this is where a deeper insight emerges. These models are very good at learning patterns in features, but they completely ignore relationship between entities. That is a major limitation. So the purpose of this episode is not just to build a model, but to expose its limitations, because only when we see what ML cannot do, we understand why we need something more. In episode 3, everything changes. This is where we stop thinking in rows and columns and start thinking as graphs. We take the same data, but instead of treating it as isolated records, we transform it into a network. Patients, providers, claims, all connected through relationships. This is a critical shift because now fraud is no longer hidden in individual records. It starts to emerge as patterns in the network. But there is a challenge here. Most datasets do not explicitly give you relationships. So one of the biggest gaps we address in this episode is how do you construct a graph from raw data? How do you define nodes, edges, and interactions in a meaningful way? This is where fraud truly becomes visible. In episode 4, we take the next step. Now that we have graphs with us, we need models that can learn from them. This is where graph neural networks comes in. We explore how these models work, not just mathematically but intuitively. You will see how information flows across nodes, how influence spreads, and how a node's behavior is shaped by its neighbors. One key insight here is that traditional machine learning assumes independence between data points, but in graphs, everything is connected. That assumption breaks completely. This episode helps you understand not just how to use GNNs, but why they are fundamentally different. In episode 5, we go a little bit deeper because fraud is not static, it evolves over time. A provider may look completely normal today, but their behavior may slowly drift into something suspicious. Static model cannot capture this. This is a major blind spot in most systems. They detect patterns at a single point in time, but they miss how those patterns change. So in this episode, we introduce spatiotemporal graph models. We combine relationships with time and start detecting how fraud evolves. This is where detection becomes proactive, not reactive. In episode 6, we address another important reality: not all entities are the same. In a healthcare system, patients, providers, insurers, and attorneys all behave differently. But many models treat them as if they are identical. The simplification creates a gap. So here we introduce heterogeneous graphs. We model different types of nodes and relationships explicitly. This allows us to capture richer, more meaningful patterns. It brings us closer to how the real system operates. Next, with episode 7, we bring together two powerful worlds. One is classical machine learning and graph based learning. It's a kind of a hybrid approach, right? One of the biggest insights in this space is that no single model solves the entire problem. Machine learning is an excellent at capturing feature level patterns. Graph models are excellent at capturing relationships. But when used independently, both have limitations. So in this episode, we explore hybrid models that combine the strength of both. This is where performance improves significantly and we start approaching real world effectiveness. In episode 8, we tackle something that is often ignored in technical discussions. Just nothing but explainability. In a fraud detection healthcare system, it is not enough to say that something is fraud. You need to explain why. You need to provide evidence that can stand up to audits, compliance checks, and even legal scrutiny. This is where many advanced models fail. They produce predictions but no explanations. So we address this gap by building explainable systems. We extract subgraphs, highlight key relationships, and generate evidence that support each prediction. This is what makes AI usable in the real world. In episode 9, we move from models to systems. A model that works in a notebook is not enough. Fraud detection needs to happen in real time at scale and within operational constraints. This is where most research stops. And this is one of the biggest gaps. So in this episode, we design a production grade system. We integrate graph databases, streaming pipelines, and model serving layers. We show how everything comes together to create a real-time fraud detection pipeline. And finally, in episode 10, we bring everything together. We build a complete end-to-end system from raw data ingestion to graph construction, to model training, to explainability and deployment. But more importantly, we also look ahead. We explore the biggest open problems in this space. For example, the role of attorneys in fraud networks is still underexplored. The integration of unstructured clinical data is still evolving. Privacy preserving learning across organizations is still a challenge. These are not just topics, these are opportunities for innovation. When you look at all these episodes together, you start to see a bigger picture. This is not just a learning series, it's an evolution. Sorry, already mentioned. An evolution from isolated predictions to connected intelligence, from static models to adaptive systems, from academic ideas to real world applications. So, if you want to go beyond tutorials, if you want to understand how AI systems are actually built, and if you want to work on problems that truly matters, this series is for you. In the next episode, we start with the foundation, understanding healthcare fraud, but once you see it as a system, once you see the connections, you won't look at the data the same way again. This is just no better. Where we don't just learn AI, we decode it, connect it, and build it. Thank you. See you soon.